Okay, so where we start, 21, right?
Yeah.
So this was another quadratic equation, but what's missing? What's missing? The b value, right?
Yes, the b value.
All right, when the b value is missing, you don't have to do completing the square or factoring or anything. You can just get the x squared alone. So we're going to subtract the 18 and divide by 2 first, so that the x squared is alone. Now what can I do to both sides? Square root. So when that b isn't in there, like this one, okay, just get the x squared alone and square root both sides. And what's the square root of -9? 3i. What else I got to remember? Plus or minus. A lot of you missed a few points on that last chapter 5 test because you forgot that little symbol. Okay? So, again, all of these are actual, I'm looking for work and stuff, right? We're past the multiple choice part, which we're going to do tomorrow, right?
Right.
These are the ones we're doing tomorrow. Friday will be the multiple choice part. Okay. 22. So this one I don't tell you how to do it, just to find the zeros, right? I always try to factor first. Are there factors of 18 that add up to 6? No. So you can use quadratic formula if you want. You can complete the square. You can graph it on your calculator, but I don't think you'll be able to find it very easily on your calculator graphing it. So I think I would just use the quadratic formula for that. So I'll write that. I would put this on my little note card. Did we already do one with that already? We didn't do one yet? Okay, so I always like to put my parentheses around my A, B, and C. That way I never mess up on my signs in my problem when I put it in the calculator. Sometimes if you don't use parentheses, you'll get a little different answer. Okay? So my B is 6. So -6 plus or minus. And then b squared, again, b is 6. A is 1. And C is 18. All over 2 times A, which was 1. So that's how I would do that one. Okay, so this is -6 plus or minus the square root of something over 2. So the only part I put in my calculator is the 6 squared minus 4 times 1 times 18. Okay? So 6 squared minus 4 times 1 times 18. That's a -36. Okay? Which is a nice number. Why? Perfect square. But it's negative, so it's what? 6i, right? Is that acceptable? No, it's a good answer, but it's not because we're not finished. Why? Because I can simplify. 2 goes into all 3 of those, right?
Yeah.
So I would be looking for this. Okay? You probably miss a point if you didn't go from here to there. Okay? You guys all know you're supposed to simplify all fractions, right? The lowest term. We good on that one? So that's how I would do that one. Okay, if I don't tell you to use a certain method, most of you are really pretty good at this one. quadratic formula. 23. We're simplifying complex. Actually, we're dividing two complex numbers. Okay. Remember, the square root. If this, you need to remind yourself of this. That's okay. Square root of -1 is I, and I squared is -1, right? Okay, so you might want to add that to your note card. Right? So that means there's a radical. Since there's an I down here, that means there's a radical in the denominator. We're not allowed to have that. So we have to get rid of that I in the bottom. Okay, the way we do that is multiply the top and the bottom by the complex conjugate of the bottom. So what's the complex conjugate of 5 plus 3i? Yeah, 5 minus. Some of you on the test used 5 plus. You kept the same sign. Remember, it's got to be the opposite sign. So we're foiling all this stuff, right? So F is first, -2 times 5. O for outside, -2 times -3i. I for inside, 2i times 5. And L for last, 2i times -3i is a -6i squared. Okay? Down here, first, 5 times 5. Outside, -15i. Inside, +15i. And last, -9i squared. What do we do with those I squareds? Cross them out, because they're what again? -1s. So this is -6 times -1, which is +6. And this is -9 times -1, which is +9. What happens to the 15 i's? So all the i's are gone in the bottom. That's why we did this. Right? So 25 plus 9 is 34 for the denominator. -10 plus 6 is a -4. And 6 plus 10 is 16. Can I simplify that? Yeah. 2 goes in there, right? So 17, -2, and then 8. Okay? Questions? Okay. 24 for some reason always gives kids problems, and I don't understand it. Okay? It's just two functions they give you, h and k. Tells you what h is. 2x squared plus 6x minus 9. It's a quadratic trinomial, right? And k was 3x squared minus 8x plus 8. So it says find h of x minus 2k of x. So what's 2k mean? 2 times k. Right? So 2k is just doubling them. 6x squared minus 16x plus 16. That make sense? And what am I supposed to do with that answer? Subtract it from this one, right? That's all it's telling us. So we're not looking at this now, right? What's 2x squared minus 6x squared? Thanks. -4x squared. Hopefully you're ready to answer those tomorrow. What's 6x minus a -16? No, 22. Because it's minus a negative, what is it? Addition, right? And negative 9 minus 16 is a negative 25.
Yeah.
So that's all it's asking you to do, is just double the k function and subtract it from the h function. So just combining like terms then, right? So it's not that difficult of a problem. Right, Olivia Wyndham?
Right.
Okay, okay? Again, make sure you ask if you're not sure about something. All right, 25. You're given another quadratic function. Does it open up or down? Up, right? Axis of symmetry. What's the little formula? Yeah, x equals negative b over 2a. Okay? So negative b is positive 12, right? And 2a is 2 times 3, which is what? 6. What's 12 divided by 6? 2. So we got 2 of our 3 answers. And then I have to find the vertex, right? I already got half of it. How do I find the other half? Plug it in, right? Oh, we got to find the y-intercept too, don't we?
Yeah.
Plug it in to the original problem. So that's, oops, need a 3 first, don't I? 3 times 2 squared minus 12 times 2 minus 6. All right, 2 squared is 4 times 3 is 12. 12 times 2, 24. 12 minus 24 is a negative 12, minus 6 is a negative 18, right? And then what is the y-intercept? Negative 6, right? It's the c value. Right, so that was stuff on the last test, right? Chapter 5 stuff. Ooh, word problem. Chapter 4 stuff. 14 coins made up of nickels and quarters. So the number of nickels plus the number of quarters is how many coins? 14. That's our easy equation. They're valued at $1.70. What's the value of a nickel?
25.
Or nickel. I was thinking quarter.
0.05 or 5. Quarter, 0.25 or 25. You can do either way. Since I didn't use the decimals, what's my amount?
170.
170. If I use the decimals, it'd be 1.70. Okay? That's the only thing that you got to remember, really. Now, you can use elimination or substitution or whatever, but how did we always do these when we did these? Is that how you do it? That's okay. Didn't we use the matrix way? That's what we did on the word problem. Once we got the 2 equations, we did the matrix way. So what's my A matrix?
1. 1. 5. 2, 5. 5.
And remember inverse. What's my B matrix?
27.
Equals. I don't have my answer, so what is it? 9 and 5? So 9 nickels and 5 quarters. Okay? That's what we did before. But again, once you get the 2 equations, you can use whatever method you like. Okay? But that's the quickest method, right? We got to do that for the last one, too. 27. This was some of the stuff we talked about last week on section 6.1 and 6.2. Put it in standard form. So what's the first number? The negative 9x to the fifth, right? The biggest one as far as degree, right? And then the minus 5x to the fourth. And then the minus 7x cubed. And then we have a positive x squared. And a negative 14x. And a 6. All right, so that's the first step, standard form, put it in the correct order. All right? Identify the leading coefficient. What is it? Negative 9. Degree. 5, right, it's that first exponent. And then number of terms.
6 terms.
1, 2, 3, 4, 5, 6. That's a tough answer, right? Hopefully we're not going to miss that. Okay? 28. It's subtraction. It says add or subtract, but there's a subtraction sign between them, right? So we got this trinomial minus this trinomial. All right, so what's 2x squared minus 6x squared? 4x squared. 5x minus 2x. 3x. 10 minus a negative 50. 25. I'll mess up on the minus and negative part. Simple, right? You can do it, no problem. If I could write, it's pretty good
Mr.
though.
Manley, I have a question.
You do.
For the last one, I thought that was a negative sign, so that.
Oh, did I write it wrong? It is a negative thing, you're right. Good catch there, Wendy. I was just seeing if anybody was paying attention. You're the only one paying attention. No, I did that on purpose, right?
Sure you did.
Yeah, I'm sure I did. So it's not 25, it's what? 5. Sorry about that. Okay, 29. We're going to find the product, which means multiply, right? All right, so how many terms when I get finished multiplying? 6, right? There's 2 a binomial times 3 a trinomial. That's going to be 6 terms. Now, if there's some like terms, we might not end up with 6 at the end. But when we multiply that first step, we're going to have 6, okay? So 2x times x cubed is 2x to the 4th. 2x times negative 3x squared is a negative 6x to the 3rd. 2x times 2 would be 4x. 3 times x cubed is 3x cubed. 3 times negative 3x squared is negative 9x squared, which there are no x squareds, are there? So let's put it over here. And then 3 times 2, 6. So I only have one set of like terms. All right, put it in the right order. We got my 2x to the 4th, negative 3x cubed, negative 6 plus 3 is a negative 3. Now let's put the negative 9x squared next. Put it in the right order. So we have 5 terms actually when we're finished, but when we modify, we have those 6. Questions? That's pretty easy, right? Okay, the last one is that investment type problem. So we did those on chapter 4 also. Okay, so a banker is investing $4,500, okay? So he's splitting it up into 2 investments. So the amount of money from the first investment plus the amount of money from the second investment was the total amount of money, which was the $4,500. That's your easy equation. When you find interest, when you do investments, you multiply the percent, yeah.
I don't have that problem. My
Oh, yours isn't 4,500?
No.
What's yours?
450.
Raisins and
Oh, really? I don't know what that is.
nuts. I was
So it's a mixture problem?
Yeah.
So why is mine different than this first? I don't know. All right, sorry.
You almost have to see the problem.
Yeah, sure.
I mean, I just wrote the over on it.
All right, so this is one of those mixture ones. We're mixing nuts and raisins, and how many total kilograms in when I put the 2 together? How many total kilograms, what does it say? 55, right? So the number of kilograms of nuts, we use N and R. Number of kilograms of nuts plus number of kilograms of raisins is the 55 kilograms total. Okay? The cost of a kilogram of nuts is $4.50. So, if I got 10 kilograms of nuts, it cost me $45. Okay, just multiply, right? And the cost per kilogram of raisins is $3.35. So if I had 10, kilograms of raisins, it cost me $33.50, right? What's this mixture gonna cost me? $3.80. Okay, what's it actually gonna cost me since I know how many kilograms there are? What do? I gotta multiply it by the 55. So that's the part that usually we forgot to do was we have to multiply the 380 times 55 for that answer. Once I get the 2 mixtures together, I'm looking for the cost. And that's about right, Nuts are more expensive, raisins are the least expensive. When I put them together, it's gonna be somewhere in between those 2 costs, right? 380 is between those 2, right? So that's, and again, I would just do my A matrix. 1, 1, 4.5, 3.35. In my calculator, inverse, and then 55. And you can just put 3.8 times 55, and then whatever that, once you hit enter, when you're putting it in your matrix, it'll give you that answer, whatever it is. So what's that come out to? 21.5?
Yeah, for the more.
Okay. It's probably like 0.52 and 33.48, is that what you said? So this would be how many kilograms of nuts, and that would be how many kilograms of raisins. And that's 55 if you add. Okay? Let's just go over this one in case it's an investment one tomorrow, number 30. It's a mixture or an investment one, so I'll go over it real quick with you. This is what it says. A banker invested $4,500, part of it at 6% interest per year, the rest at 8.5% interest. The total interest for 1 year from both investments was $320. How much was invested at each rate? Okay? So this person has a $4,500 that he's splitting up. So the amount of money in the one investment plus the amount of money in the other was the total amount of money he had to invest. Okay? So this amount was 6% interest, so you multiply by 0.06 when you put it in the equation. The other one was 8.5%, so you multiply by 0.085. Why? That's moving the decimal point 2 to the left. Equals how much they made in interest, which was $320. Okay? So if you have that type of problem, okay, you set it up that way. Then I would do the matrix again. So you have 1, 1, 0.06, 0.085 for A, inverse 4,500 and 320 for B. Which would be, let's go ahead and I'll do it. $4,500, 320. A inverse B. So it'd be 2,500 and 2,000 is how much is put in each investment. Okay, so it could be one of those. All right. Any questions about your note card? Or,
You need 24 again.
sure. So what we did, we went and said, this was the problem, do this. And they gave you the two functions. So you double the K, all the numbers in the K. So 3 became 6, -8, -16, and 8 to 16. And then it says just subtract. So I just subtracted the 2K from the H to get that. Any other questions, Jamie?
Is the note card out front and back or good?
Yeah, front and back. Okay? Gotta be 3 by 5 one, and then you'll turn it in to me Friday when it's all done. Any other questions? All right, so you just be here normal time tomorrow. And we'll do numbers 20 to 30, like the ones we just did first.
And also tomorrow, I should be able to take the unit